Hello everyone, welcome back to OB Nexus Computing, Computing from the Heart. Today I want to speak about a package I've been working on called Phantom ID. Phantom ID is a anonymity code, anonymity, uh, an anonymous account creation package, like we can see. It's focused on privacy and security. The two concepts of Phantom ID are introducing link and privacy for security. Um, Phantom ID, being a C package, solves the problem of privacy and security, which is a debated topic. Whether should prioritize more on privacy to enhance security, or security to enhance privacy. I've solved the problem. I've solved the problem by by making sure that privacy and security are linked, are intrinsically linked. The more privacy on the network, the more secure the network is. The more secure the network is, the more privacy it gets. So you get the best of both worlds. The debate is quite historic and practical about what should, in society, whether we should prioritize privacy or security. But I don't see them like that. I see them as intrinsically linked as one thing, and more privacy equals more security, and more security equals more privacy. And the Phantom ID code base is actually can actually use it now, but I'll explain the proof of concept in the next in the now. So let me just switch, but I'll show you how it works in a conceptual manner, or what I call the proof of concept. So this is how the Phantom ID proof of concept is structured. I minimize it to three structure at first, and this is how it actually works under the hood. You can see that here we have a root account and child accounts and child accounts. Um, this is how the Phantom ID account works. This is how it works. This is how it starts off and this is how it ends. To make when the network initiation. So this is start, and this line limiter to um for the for how it operates, how it works when the setup or the constructor has finished initializing on the setup method. So it's simple. In the simplest method, is we have a root account. We have a root account in the Phantom ID network using a tree-based structure, and we add child accounts, which are admin accounts. And root account this root account is a daemon. Uh, it's not a daemon. This is just a root account. It's just a node. So it's a node on the network. It's actually an account. So think of it as a node on the network, a person on the network, or someone that's using the network. Um, well, he has no one. He has no inherits. He has all these are child admins and or child accounts. You can these are child accounts. No, this is just a simplified model. And it's just bad. I've seen some problems with this model as well, so it has to be updated. Just a proof of concept again. So this account, this root account, and the root account just is created on instruction, and you add the child accounts. When you're adding the child accounts, you then add them in a tree structure or the graph structure, which is what stands for networks, which is just a simplified model. Don't use a tree in a real life implementation. That's very bad because you can have a lot of errors as well. Some technical errors due to security of if this root account get intercepted or whatnot. But so use a graph based structure. This is just a tree, and that's you make the accounts, and then you then move to step two. This is the first step. When you finish making all the accounts, the two accounts here, you open the accounts. You delete all the connections, all these connections here, and this is the next step. And do the root accounts, opening these accounts or opening a graph tree structure, and that's makes the admin accounts inherently inherit permission and everything before you can inherit all the permission for the root account, and then you can just delete all the other child accounts. Often, so these accounts have no connection to the actual root account, and that is 100%. This is anonymous. So, but what's keeping those processes alive is daemon. It's not really strictly here, but daemon, a process runner, something that keeps the process alive, is running behind the background, and that's called a phantom daemon. Um, Phantom daemon keeps the process alive throughout this interaction process of the Phantom ID account creation and deletion. And that is the core of Phantom ID. So in simple layman's term, you have an account, you create an account, you create all the children account, on the graph anywhere, and then you connect them anywhere in the world. And then you when you're done, you go down and delete all the collections and all the risk accounts. and often all the child accounts. Okay. I'll show you now how I verified the integrity of this structure. So now everything's orphan. We have new problems introduced to the to the to the system. Okay, now before I continue, I would like to say that to subscribe and hit the subscribe button at the bottom. It's right at the bottom here. With here, it's right along this place. Hit it, smash it, and share this video with all your friends and family so they can learn and see, learn about, and support me. Um, on my support me and my work. So now we'll talk about the Phantom decoder and Phantom encoder. Okay, the Phantom decoder is it's a simple mechanic to authenticate on the network. Authentication is simple. It can be easily done in Phantom. It's very easy to do authentication in Phantom network because um, authentication is supposed to verify the user, but verify user is who. On a phantom network, it's hard to do that because of the depletion. So there is actually a simpler way a workaround I found to make sure everything works together. Phantom decoder is it's actually a class. It's meant to be. I'll show you the implementation here and I'll demo it. But what the phantom decoder is in a nutshell is using encoding for you takes the signature an encoded signature of an encryption. What I mean by that is like uh, uh, um, when you encrypt something, encrypting is a form of encoding. That's what it is. But secrets, completely secret. The secret form of encoding. But you have encoded characters. Encoding just changing forms of changing one form to another. Data, structured data into one form or another. That's encoding. You change the format so it's more applicable or more useful. But the phantom encoder, phantom decoder and encoder, it's actually works the phantom network by making sure that encoding um, is uh, encoding is taken from an encryption key. Uh, if you use any SHA-256, don't use MD5. That's terrible. You fail your computer. Or SHA-1, any algorithm. So you have an encoding system behind the encryption, and that's what authenticates you on the system on the network. So if you have, you say zero knowledge, I call it a zero knowledge authentication, I believe, because it just checks the encoding. If the encoding matches the variant of the matches the form of the encryption, then you have authenticated user. But the encoded key is a form. It's a more public. It's more encoding used for publicity. You can reach an encoding key, but you have to check it. You can keep it secret to validate that data's integrity or that person or that node's integrity or that person on the network's integrity based on the encoded key. I'll show you an implementation now. Okay, hello everyone. This is the Phantom encoder class. This is Phantom encoder class in Python. Okay, on the screen right now, it's what's known as a Phantom encoder. It's like okay, so it's how authentication happens on the Phantom network. So every node and data is like again, like I explained before, we have no connection to the node and data, so we just have zero knowledge. We have zero knowledge of who's who on the network, and the knowledge, the encryption. How this phantom encoder works is by getting a basic. You can use a basic 64 representation and representation as an action encoding, a valid encoding scheme on standard or anything. But it's a simple example. This is just a map of characters, and that's just a simple encoder. Um, and I'll just run the demo. This is just a class. I'll put it on the description below. So feel free to check it out. I'll put it down in the bottom. So I'll show you. I'll just run it for you guys to see whether it works, to see where it works, and see how it's used. Okay. It's just a little demo, but how it works again is you have an encoding key. You have not an encoding. You have an encrypted data, and that encrypted data has to signed by an encoding, signed through an encoding. It's check that's like checksum of the encoding. Like you map it to basically full or some encoding format or valid encoding scheme. And that secret is probably if you just keep it private as well. You used to check people, but you should check people on zero knowledge on the network. So if everything is created, you then encode it, encrypt it, encode it, and then validate you send the correct message to the recipient through the encoding, not checking the system. Because to check the system, you have to then see who's on the encryption key, which takes a lot of time, and you can't do that on a Phantom ID network because the encoding, the encryption is there, and you destroy the root account. It's no connection. It's no known connection. So that's why the encoding has come by. So the Phantom encoder is what gets you the data from the encoding scheme, encryption scheme. Sorry. So let me show you a demo now. So this I'm going to run this Phantom decoder, or Phantom dot slash works. Okay. So this is uh so this is just a demo. Follow Phantom ID one verification key, and then derived ID, and this is just data. So you could run it yourself and see what it like, see what it is on your system. If you like it, you can use it. But it's going to be part of a Phantom ID network. Just make sure you support me, and if you like it, you want to use it, like and subscribe. Make sure you like and subscribe and share this video. Okay, this is a Phantom decoder. And this is zero knowledge zero encryption. So we don't actually know. We just check the system for the encryption key, and that is what Phantom decoder is. So we run it. We see that the general Phantom ID is this string. The version key is this string, and just want to. And the version ID is true. We verified, of course, verified, and then the derived ID is this is encoding key. This is D1 dot. That is what it is. Uh, Thank you and goodbye. Subscribe, like, share, subscribe, and this is OBNX's computing. Sign off. OBNX's computing. Computing from the house. Hot. Signing out. Thank you. Bye bye. Subscribe, like, and share with all your friends. Bye. Bye. Thank you. Thank you for watching. Thank you all for watching. Bye. It's gonna be on GitHub as well. And GitLab, not on all my social media. On GitHub, OBNX's computing says guests, the guest page. Check out OBNX's computing on GitHub, on Substack, and TikTok. So this will show you this system is going to be Phantom IT, just a network. And make sure to share, like, and subscribe because this is an anonymous network which is building. It's like it's 100% anonymous. It's very decentralized and it works perfectly. You just need implementation and people to work on it. And that's the Phantom ID decoder and Phantom ID network. Thank you very much. Bye bye.